I'm just catching up here on chapter 10 notes, and it's probably one of my fun ones because this is kind of the culmination of the different three-dimensional shapes we work with our solids. And today we're talking about spheres. And with spheres, like some of you just go, ball. Well, yeah, that's exactly what it is. But of course, it has a very specific definition, and I like this definition. A sphere is the locus. Now, locus means set, okay? It's the set of points in space excuse me, that are a fixed distance from a given point called the center. Now the center is just like what you would think it would be on a circle. It's just the center of it. It's where everything's located. It's like our location. If we didn't have the center, we wouldn't know where the sphere would be in space. And so when we work with that, we are going to actually use one piece of information to describe it. It's that distance from the given point. Well, what's that distance from the given point called? Yeah, that's called the radius. And the radius just connects the center to any point on the sphere, so it can like spin in any direction based off of that center. So right here we'd label our radius when we're doing that. And then we also have a couple other terms that are actually very helpful. The first part is if you take half a sphere, you have a hemisphere. Now remember in geography you talk about the northern hemisphere, southern hemisphere. We have the western and eastern hemispheres. It's how we're divided up. The same idea kind of happens because we're talking about the sphere. Now, a sphere itself is just a ball. It has no base. So we'll have only surface area. But if you have a hemisphere and you take half of it away, you're going to have a circle for a base. So a hemisphere can have lateral area, but the cool thing is for a sphere you can only have surface area because of it. Now, so we'll just name this your hemisphere. Now I'd make sure I would know this. This has been known to show up on tests, so make sure you know this one. And then if you can divide the sphere exactly through the center, smack dab through the middle, you are going to get what's called a great circle. Now that circle, make sure I label it right here, is the largest circle you're going to be able to get, but you can get it going through. So basically it's like the bottom of the hemisphere is what your great circle would be. And the cool thing about the great circle is we know if I'm solving for the surface area, and it's been found that the area of that circle, because the radii could go right there, correct? 4 of those would cover the surface of the sphere. So the surface area of a sphere is 4 pi r squared. That's it. We only have to worry about our radius. And then we have our volume. And once again, all the other volumes was area base times the height divided by 3 or not divided by 3. A lot of confusing things. But here's the thing about a sphere. The only real important piece that we need to know is the radius. And another sidebar, how you calculate the volume of the sphere is actually using Cavalari's principle and cones. Now, you can come talk to me more about how that would work, but it's really kind of a cool thing. So your volume, though, I'd write it like this: 4 pi r cubed over 3. Now, some of you would go 4/3 pi r cubed. I prefer the first one. And remember, when you're doing your order of operations, you're going to have to cube your radius first, then multiply by 4, and then the pi a lot of times will come along. Don't forget to label these correctly, but make sure you know your 2 formulas, okay, and your definitions about a sphere. Now remember, the definition of a sphere is the same thing as a circle, so for a circle we say in a plane, and on a sphere we say in space. So that's what keeps one 2-dimensional, the other in 3-dimensional. All right, we're just going to flip it over and work some problems together.